start? I can't hear you. The sound is off. Now I can.
Okay. After 5 minutes, we can start.
Ok. Thank you.
Ok, benissimo. Sardi, io punto su di... Sì. Eh? Va bene, ok, ok. Vieni, vieni. Sì. Eh? Ah, prendi una sedia e mettiti là. Sì. Ah, sì.
Buongiorno Matteo Villa. Good morning. Nice to meet you.
Nice to meet you too. Good morning, Maria Teresa.
I'm a teacher of English, usually leading the meetings. And thank you for having us today.
Thank you too.
Thank you.
Okay, probably we have to wait 5 minutes
Yes.
for all the students. Okay.
Okay.
It's
Have you
fine, it's
already agreed at the end of the meeting?
At the end?
Of a meeting that is by, let's say, 12:45, 12:50. Is it okay with you?
Yeah, it's fine. It's fine.
Okay, thank you. Because in the end, Corrado, my colleague, has to take some students back to their school. Okay.
Oh, no
And
problem.
then
No problem.
at 13:10 we end our school time. Okay.
It's fine. It's fine.
Thank you.
Maria Teresa, the Scottish colleague have problems for connection, and now we
Okay,
can start.
You need to restart?
We can start with the presentation.
Okay. Okay, thank you. Okay, so we can start. Thank you.
Okay. Okay. So I think, Maria Teresa, if you want, you can recording the screen and the entire lesson if you want, without problem.
Okay, thank you. I think that the staff will provide for that. I'm in another classroom because I couldn't ask for a change. So I am connected using my laptop, while Corrado and the rest of the team, our staff, which is behind the camera, and the audience are in another room, which we call it's a sort of multimedia room. So we are separated, but together.
Okay, perfect. Okay. So let me see. Okay, let me check if you see my presentation. Just a moment.
Okay.
Okay. Okay. Give me a feedback about my screen. If,
okay, I will.
okay.
Yes, we can see. Okay.
Okay. Okay. Okay, so we start the presentation with in the first approach with Planetek, the short description of the company, and after we will make a presentation of EO introduction environment. So The goal of the AO introduction is give to you, in general for students, some advice to manage the information in the future. Okay. And after my colleague Giuseppe um, present some examples of the real use of Earth observation. So in this case, you can have uh, a, a good overview of the environment system of Earth observation. Okay, and for the students, if they have some questions or if they want more, I don't know, more specify some argument, can you interrupt me or raise the hand or something like that. Okay, you are free.
Usually, we leave some minutes, let's say 10 minutes after your intervention for some questions.
For
We
sure,
usually
no
do
problem.
not interrupt in case they will raise their hands. Thank you.
No problem, no problem. Okay, so um, good morning, everybody. We are Planetek. I am Matteo Villa, and I am Senior Technical Specialist of Geoservices. In general, my profile is to the first time in Planetek, I developed algorithm for Earth observation analysis, in general, like informatics stuff. But my background started with geology. So I have uh, I have to rise up and update my skills during my trip in Planetek. In general, I am the with Francesco Albanese. I am the tutor and the coordinator of education and corporate academy in general. This is an example. So, Planetech, a short introduction. Planetech now is in the group, in the orbit group. Planetech have some headway. So the orbit have multiple office in the Europe and in general in the America too. And Planetech have two main office in Bari, where I live, and in Athens. In this case, it's Planetek Hellas, Planetek Italia, and the orbit is a main part of the group. I write here some place, not all, but some place, the main place where the group is active. In general, Planetech was born in 1994, and now we have one up to 140 people. And in general, the profit of the company is more than the 30 million per year. In general, Planetech makes um, some red line and some pipeline very strength in the Earth observation process. For example, processing of satellite in general, so aerial, drone, and make a cartography and geoinformation, and continue Earth monitoring with satellites using AI. And we will see in the next slide a project named AX, when we try to make a processing inside the satellite, but in the future. In general, you have to know Planetech make a continuous Earth monitoring. So, design the implementation of marketplace and downstream infrastructure, because in this case, we need to make a good environment for the satellite data too, not only the satellite to take the information that we see, but in general, we have to make and design the good implementation of all environment stuff. And after, software engineer on board and ground segment of AO mission operation. So Planetech decide how to manage the ground segment and the ground coordination of satellite, and we will try to make a future in this way to manage the processing directly inside the satellite. I want to say that Planetek is a benefit company, so we are strongly committed to operate in a responsible, sustainable, and transparent way. So that's why all of our project is in clear in the website and in the publication, like a ResearchGate website, like academia website. So you can find a lot of information of our project. It's not a closed system, it's like open system. This is why we call benefit company and all this justification that they concern. In this slide, I put some partnership because I don't know if the students know some names about it, but it's good to make a good overview of Planetek. I think it's good to make a slide with our partnership. The big name of the partnership, like Hexagon is a geospatial software company, and in general, satellite imagery. So Vantor, Airbus, Planet Image, and Copernicus for sure. So we use now we can start to see and to understand that we use a very high resolution image like Planet, Airbus, and Ventor, and we use open and not open geospatial software. Like Hexagon is not open; they have license, but in general, we use this instrument to make our job. I put this slide. It's a little bit boring, but it's essential for understand that the company, like a geospatial company with like Planetek, sometimes the students said, okay, in general, geospatial company have remote sensing, satellite, and image. It's not true. It's not true because inside the company we have a lot of section like a space section, etc section, energy transport. So um, our customers divide and mm, is divided by the goal of the company, like energy. One, for example, we think aerospatial company like Planetek or remote sensing company, it's the same in this case. We think, okay, energy, okay, not fit very well. But in general, energy, like any total Saipem Terna, call to us for make a solution or monitoring stuff for their architecture or infrastructure. So this slide, the goal of this slide is for make you an idea that uh, remote sensing in general take a lot of point of goal, not only space, not only environment in general, but transport, energy, and etc. This is the goal of this slide. Now, I want to make a very quick overview of the business unit inside Planetek for make you an idea where Planetek and how Planetek makes service. We have three business units: space stream, government and security, and business to business. In general, business to business is in every company, they have this business to business section. Okay, um, it's a small and large company. I mean, and Space Stream is a particular part of a company and government security that I work now. Um, I try to explain better. So this company, my company, make a service also developing service like a technician staff, or in general make a solution in higher level. So we take a contact with client, with customers, with institutional stuff, and we try to make a solution that fitting very well with the goal of the customers in this case. And I put here in the slide some example: environment monitoring, spatial infrastructure, smart cities, open data, and civil protection and defense. In this case, I want to put a slide with IRIDE, IRIDE is a consortium that we make for make is it will consist of a constellation of 36 satellites. Is only for Italian part, I say this, of variation types of size, which we build in Italian complete in 2026. And we are actually replying to ESA tender with a signed agreement and consortium colleague OSIRIDE, the consortium. So this is a solution for a 36 satellite to Earth observation and monitoring Italia place. Now I said business to business is so easy to understand because it's a company to company, business to business part of Planetek. It's not my case, but in general, for for the students, I think it's important to know that exist this part is fundamental part of the company that make contract with another private company, energy and oil gas utilities, infrastructure engineer like Terna, like Saipem. This is company for the energy and infrastructure and mobility too in Italy, like Autostrade for Italia, for example, and Infomobility. Okay, this is a quick overview of business to business. Space Stream is only for remote sensing company in this case, or geospatial company, and is more technical part because it starts to involve onboard software, ground segment, and exploration. So the technician of our company start to elaborate data and programming the software and the hardware inside the satellite. So this is a space stream business unit that have the business part, but in general, the main part of the space stream is to develop and make a solution inside the satellite and the ground segment exploration. This is the goal. I said before, the IX project, I want to say to you, in this case, this slide, the goal of this slide is to give to you a quick look of the future, because in general now we have, and we see in the Earth observation introduction later, we see the satellite have some latency, so the time to transmitting the data to the Earth and this kind of stuff. We try to manage it, directly develop the solution inside the satellite for process the data and send to the Earth directly the data after processing. Now it's too easy to see to say that, but we have when we work with the space in general, we have to know that we can't make an error. Okay, because it's not like infrastructure stuff or design the service in the Earth, like a building stuff. The space is so easy to say, but you can't manage the satellite when the satellite are in the orbits. It's so easy to understand. In this case, we have to um, design and manage the project very well. So that's why I call it the future, because if the service start to be um, active, we have a lot of benefit that we will see in the Earth observation introduction later. Okay, I go. Now I want to say to you, in general, this is a Planetek Academy course that I will do and my colleague do, and for sure, I want to give to you some advice, like you can go to the Planetek website and go to Academy part, and you can see the Earth observation introduction, not like mine, not like the that I will do, but in general the remote sensing courses or the SAR courses that we will see. In general, we collaborate with a lot of university. That's why in the website you can find this. This is the page. I give you the slide after this lecture, so you can check, you can try to make some courses. It's free. We have premium account and free account. You can use free when you want. You are free. And in general, target membership or education field is Copernicus, because Copernicus are free data that I will say later. But in general, Copernicus Academy have a good stuff to learn. Okay. So if there is some question, I finish my presentation of the
I do have
plan.
a question, even if I told you before in advance, but we we usually left the questions after. So when you
Yeah.
hold collaborations with universities, what is the goal of a collaboration? Can you give us an example of, for example, a recent project that you had with the university?
So in general, with university, if I understand the question, during our collaboration with university, we make a courses in general. So we make a introduction, like now, introduction of Earth observation theory, and we try to make sometimes some exercise with the lessons. So we give to them some open data, and we try to make together a result for
Okay,
using
so you
geospatial
analyze
approaches.
the data, okay, that you collect
Yeah.
with your
But not
services.
so much, not so much, Maria Teresa. In general, we make a lesson, frontal lesson, but sometimes we do some analytics task
Tasks.
too.
Okay.
Yeah.
Okay, thank you. And what
Okay.
about security in this period? Because I thought about security, and so about, for example, countries which are
Mm.
at war. So do you have restrictions in this period with your apps? Is that right?
So it's a good question. In general, we don't have a lot of restrictions, but we are a reseller of imagery pack sometimes.
Yes.
So with the country that's involved in the war, we don't have sometimes satellite data because the provider stopped to give image of the country, for example.
Yes, because it can be risky. That is, you can
Yeah,
get with data information which
you're
is
right.
dangerous. And so yes, but you shouldn't have. Okay. In fact, I thought since it's an observation of the Earth, it may happen that some areas at war may be involved, and so you are restricted. Thank you
You're
so
right.
much.
You're right. No problem. You're welcome. If there are other question, please, or I start with the EO learning introduction. Okay, I start to take other presentation. Okay. Okay, guys. Now we enter in the deep hole of the understanding Earth observation stuff. I try to don't go in deeply in the technical part. I try to make a high overview, and when I go too deeply, maybe I say to you, it's not important to understand everything. So I try to manage um, the knowledge in this case. But in general, we try to understand Earth observation. I I want to organize this slide in the key concept for understanding this magic word. The first one is satellite in space. So understand what is the satellite. Second one is what is satellite data. After these two sections, we start to analyze the product of the satellite. So multispectral, optical imagery, and radar imagery. And after, in the finished part, I want to give to you some use of remote sensing technique. So in this case, we try to cover all the high level for understanding Earth observation. Okay, okay. So we can start this. How many satellites are currently orbiting in the Earth? Over 7,000. Okay, so the Earth is like a completely cover of satellites. There are some different kind of satellites that we will see. Sometimes we use for navigation satellite, meteorological satellite, radar satellite, and Earth observation satellite is our case. Okay, but the goal of this slide that you have to take is there are a lot of satellites. There is another problem because there is a trash of the space. It's another side of Earth observation because yeah, the space don't have limits, but the part of the Earth to manage the Earth observation have space limits because you have to imagine that every single satellite of 7,000, for example, every single satellite have the orbit, a specific orbit that we have to prevent the possible collisions for all the satellites. So it's not easy to understand. It's not easy to manage this, and the trash of space for dead satellite or some satellite that go in the down about software inside have to manage it. But it's another side of association. We don't take this topic today, but it's good to you students to give this idea, okay, this topic in your head. Okay, now we start with the first key point, satellite in space. Where are the satellites located? In general, many have to observing satellite orbit at altitude around 700 kilometers. I make here the uh, the the idea for make an idea how many are 700 kilometers in like a Firenze-Bari distance, you know. So the many satellite of Earth observation go in this kind of altitude. Okay, and I make here a quick overview, not beautiful image but for you maybe it's the first time to approach with Earth observation. You have to start to make an idea. It's like a onion distribution of satellite in a different altitude. Okay. In this slide, I want to specify mm, which kind of satellite, the main kind of satellite we use, uh, not only Planetek in general, the remote sensing company use. Uh, there are three main um, satellite depends of the orbit overview. The LEO, low Earth orbit, so in this range of altitude, and the approach is a fast orbit, like you can say they can make a uh, um, very quick fly on around the Earth, and they have low latencies. In general, these kind of satellite require constellation for continuous coverage because they depends from the ground segment station. So in case of Copernicus satellite like Sentinel-2, we have two satellites uh, in the opposite positions and rotate around the Earth and pass every 5 days in the same point in the ground control to transfer the data in the Earth. But we will see later more deeply. In general, there are another satellite overview, MEO, medium Earth orbit, mainly used for GPS and navigation system when you need GPS for the common use with the phones and for technical use with the defense part or in a emergency situation. In general, this is used for GPS navigation. And there are another kind of satellite is geostationary orbit. Is um, they move far away from Earth, and this is for we will see it later in this slide. We will for stable wide coverage, ideal for TV broadcasting and broadband. So they need to be stable with a lot of latencies, but we don't care about the time of transmission. We care about the stable idea. This is why the geostationary satellite works. And I make this slide for uh, give to you an idea about the difference of transmission of the data, because in this case, in the previous GIF, uh, we see the example of Sentinel-2, for example, go around the Earth and take information. And when they pass to the ground station, they give to ground station the information and the company processes information. The geostationary is not work like this. Geostationary directly stay in the same orbital condition, so they make all of the stuff to give to ground motion direction and station without wait the completely revolution of the uh, of the trip of the satellite. This is a concept. It's fine. I don't want to go deeply with the mechanics or transfer information, but um, I want to give you an idea, simple idea. There is a different kind of satellite and different use case. Okay, depends the latency, the stable, depends what the people want to do with this information. Another slide at what do satellites do? Earth observation use satellite to study the planet in general. So the Earth observation satellite. We can say in general, satellite take photograph of the Earth, and the important part is they collect data. So the temporal part of the collecting data start to give to us an idea that there exists a temporal part of the Earth observation study. So we will see later, but in general, the temporal part is the most important uh, part of Earth observation uh, environment. And this satellite, they help help us to understand what is happening on the planet in general. So we use to monitoring forest, oceans, glaciers, or cities. All of these, for example, forest, oceans, cities, we will see depends of what kind of photographs we do and what kind of analysis of this photograph we do. The forest probably need a different approach to analyze this photograph for make a good analysis. The cities need a different too approach of processing. So in general, satellite of Earth observation make a photographs, but depends of our part after the ground station transfer. We have to make a good analysis, a good pipeline for a specific topic to analyze. Okay, now I want to approach this part of capture. What is satellite data? And I make here the four guidelines for choosing satellite data or for the correctly interpretation of this. I think this is the four main properties of satellite data. There is spatial resolution, spectral resolution, radiometric resolution, and temporal that I previously said. Now we analyze all of those properties, and we will see the main characteristics and why it's important, what we change in the different way of spatial resolution, spectral resolution, and so on. I start with spatial resolution. In general, spatial and temporal because are alienated, but I want to focus in spatial. I put here the graphic that put in the ordinate axis the resolution, and here the year or evolution of satellite. In general, you have to know that every satellite have different spatial resolution value. The spatial resolution value is a minimum pixel that we can distinguish for the other one side by side. In this case, I make this an example for high spatial resolution, medium, and low spatial. There are three different images from three different satellites, and the first one have high spatial resolution. I mean, in general, I think in general, the students or the people in general think the higher resolution is better. So if I have to make an analysis, I have to take the higher resolution spatial for sure. It's not true. It's not true. Depends. Depends of which analysis I have to do. If I have a large scale, like I have to analyze all Italia country, I don't need high spatial resolution because for land use classification, it's became worst. It's bad result if I use high spatial resolution. If I use low spatial resolution, make a better land use for the large scale, better use of weight of data. So if I have to storage after the result, it's better way to make a low spatial resolution. If I have to analyze a crop file, specific crop file with high resolution for, I don't know, tomatoes culture, okay, I need probably the high resolution or medium spatial resolution because the scale is too small. Okay, this is the concept that I want to give to you. So the main concept is there are some kind of spatial resolution for different satellites, and not every time the high spatial resolution is the correct way. Okay, this is an example. Uh, is an example of the interpretation of spatial resolution for the land surface example. If I choose for analyze this kind of real land surface, a spatial resolution of 1 pixel is equal to 1 square kilometers, it's impossible to see nothing because the pixel is too large to uh, take a difference for the um, forest, water body, and urban area. If I choose 1 pixel with this spatial resolution, I start to um, um, I start to make a good result of the classification of the for the service, for example. So it depends. Depends for how which kind of service I have to do. There are the second property is spectral resolution. So you have to know, in general, the sensor for optical and radar take the information from the Earth, and we will see there are two different ways to take information for the sun energy or from the active satellite. This is we will see later this kind of difference. But in general, you have to know the satellite, the sensor of satellite, take a spectral of a spectral of radiance inside himself. This spectrum of radiance have some different wavelength. I put this diagram that the optical sensor take the visible part of the wavelength that our eyes can see, and the other part that our eyes can't see, like an infrared part and the ultraviolet part, for example. We will see after why this is important, but in general, you have to know um, that the satellite is not a simple photo, but inside this photo have a lot of information about the spectral part of the body that the satellite analyze. For example, water body or forest body have a different kind of reflectance that arrive to the satellite, and we storage all of this information of wavelength in a picture. The name is raster for us, but in general, we storage all this information. Okay, not only RGB, like a red, green, blue, like a simple photo JPEG in the reflex part, in the photo machine. It's not simple like this. We register in the raster all the information of the spectral part. And we use this for make analysis. Now we talk about radiometric resolution. Radiometric resolution, they is it's important because define how the pixel inside the image contain the information. So if I use a pixel with 1 bit of space, I can only make a classification of my image in two value, 0 and 1. 2-bit start to 4 kind of a number, possibility of number. 4 bits, 16. So I put this example of the classification of image, and you can see in two levels. So uh, the uh, the lowest part of the resolution, the radiometric resolution, we can see only white and black. But in 16 levels, we start to distinguish uh, uh, a lot of bodies, a lot of object inside the feature, the picture. So the concept of this slide is radiometric resolution represent the sensor ability to distinguish different gray levels of image. And the last part of the properties is temporal resolution. So satellite orbits around the Earth, and they can observe the main area in a different time. So I put the example here in 2015, 2018, and 2019, the same area. It's important, this kind of stuff, because we can make a collect data and we can make a multi-temporal analysis for the same zone, for the same place. Okay, this is the goal of this slide, and I think is the one of the most important properties of satellite data, the temporal resolution. Okay. Now we approach the product of the temporal of the Earth observation data. Now we start with multispectral optical imagery. So I take the spectral diagram that we will see, that we saw before, and I said there existing too many two kind of satellite sensor, optical and radar. Now we analyze the optical. So optical generally is multispectral, so acquisition of image in multiple discrete wavelength that we already said of the electromagnetic spectrum. Okay. Now for process analyze this image, we have to make a division of the spectrum into a distinct bands. Each object has a unique spectral signature, and we using this for classification of the body in the image. I put here the image of vegetation spectrum signature. So we can distinguish the peak of this picture, and we can classify and assign for every part of the spectrum a band inside the image. So we have to start to imagine this picture is like a cube, the cube with multiple layers inside. For every band and every peak that we know and we start to analyze. I put here an example. Our image is a cube for many layers inside, and every layer have a color. It's not a color, it's a wavelength section. For example, red, green, blue, and near infrared bands. Now I want to give you this concept about false color. False color concept is that we can change for our utilities the order of these bands, of this layer. In the false color, for example, I want to put near infrared in the top one, for example. And you can see the same image if I pass, oops, no, I don't know why. Oops, sorry, my computer. Okay, just a moment. Okay, if I pass to the true color on the left and the false color on the right of the same image, I start to understand, okay, if I tilt, if I change the order of the bands, something change in the color part, not in geometry, but in the color. Okay, this is the main concept you have to know now. Okay, I make an example. For example, the plants reflect a lot of infrared light, near infrared, the N letter in the previous slide. That's why they often appear red in the satellite image with false color mode. So we can see in the left is a true color image. In the right, I put the infrared spectrum sections top in the red part of the image. That's why now I see the vegetation red, not um, not green, like I or human eye see usually. And you said me, why it's important this stuff? Now we arrive of the point of why we use false color. This is another example, and I know you know we can try we can see sorry vegetation red because the theory of false color make this in this river, Amazon River. And now we have two football stadium, okay, with grass inside. So I think this is grass start to become red. No, in this case, no. That's why it's important false color, guys, because the false color um, operating in a different way is not only visible way that the eyes, for example, now we can see okay in the first football stadium there is grass, and the second two there is a grass. No, with the false color and the infrared remote sensing technique, we can detect this grass is fake, it's plastic grass. Okay, that in the satellite you can see this. Okay, this is a short example why we use false color. I put here another technique for multispectral optical imagery for detection of objects in the machine learning environment. So only for say, I don't want to go deeply in this case, but only for say, we use all these layers of the image for training the algorithm of machine learning to detect better the object. So the concept of this slide is important to make analysis false color for training better the uh, the algorithm for detection of the object. The last of Nicola, yes, you can. Oh, sorry, I don't know. You can say now if you want, because now I start to radar part, or we can say after. Okay, I continue.
Excuse me, I
Um,
just wanted to let you know that I'm here. I've joined the library with the students, so you don't see me on the screen, but I'm here,
mm,
okay?
okay, no
Because,
problem, no problem.
yes, the lesson in the previous class was over, and so I joined the class and I'm here, okay? Thanks a lot.
Perfect, perfect. So now we approach the problem with satellite taking photos. I put this image because it's so easy to understand. What is the problem when you do a photo? If I have some stuff or some obstacle to me between me and the target, and in general, in the satellite space, the problem is the clouds. So the optical satellite, the main problem is the clouds. So I can't detect the target because I can't pass the clouds. And we invent the radar imagery. In this case, the radar is another satellite, is a active satellite, not passive, but we will see later why. In general, you have to know the radar image take this part of spectrum of the radiance of the body in the hair. Uh, there are active sensors because the previous one, the optical, take the radiance from the sun reflection of body on Earth by the sunlight. In this case, with the radar image, the satellite directly uh, throw the radar impulse, the radar signal to the object and wait and measure the time of return. That's why the measures is return time to make a distance and the backscatter change single behavior for make a measure of the displacement of the modified or shape of the shape of object. And the main goal for the cloud problem is that the radar signal can pass the clouds and we can analyze the object behind the cloud. But unfortunately, the limitation is difficult to interpret the radar signal and request a lot of technical expertise. In general, if you see this kind of image, it's so ugly. It's so ugly uh, because it's not a common image that the eyes usually see. Is a radar part. It represents the wavelength time response. Is not so clear to understand and interpret this. That's why it's so complicated. But fortunately, this is a solution for manage the problem of the cloud. And I make this example of the various SAR image for detect the ground movement. I put this video only for give you understanding that this is an example of flowing zones, uh, and I go fast. Okay, I wrap the satellite. The SAR satellite is a radar that starts to mapping behind the cloud and make analysis and mapping uh, of the Earth that flooding or the place of the flooding, so we can analyze and target the previous image before the flooding and after and make some analysis. This is only uh, a point that we had to analyze. Okay, I try to. Okay, okay. So oops, sorry. Okay, this is the last point of my presentation of the Earth observation introduction. In general, I want to show you some use case and the technique that we use for analyze uh, some part of Earth observation, fire, deforestation, glaciers, and cities growth. And I put here the example of fire monitoring. We have pre-fire satellite image and we have post-fire satellite. So we can detect with these equations the normalized burn ratio index. We can detect the fire, the burned area in this place. You have to know this equation, this ratio of different number of bands is the same number of the bands of the layer that compose the cube of image. That's why it's important. Okay. And um, okay. And now I give you another short example of this one about deforestation. We use another index and we can make analysis of deforestation with this classification of image. And the last one is the city growth that we can classify the expansion of and monitoring the expansion of the cities with the classification of the body, the previous classification of the body of the image, and we try to define a trend in the multiple time, and in this case for the expansion of the city. I put this slide about the large-scale use of the remote sensing. I want to say to you that the previous example is that in a small scale, is a small part, the city, the river, the deforestation place, but existing, and we use um, satellite data for make a model, analyze, and create forecast climate data. So in the large scale for entire Europe, entire world, entire continent, and so on. I put here some names. It's useful for you for go to the website and start to make an idea about the large scale using of remote sensing. So this is my, sorry if I go long, but this is, thank you for your attention. And this is EO Learning Observation Introduction. Now I think, I hope if Giuseppe can connect in the meeting, and maybe
I am already connected.
Okay.
Thank you, Matteo. Good morning, everyone. Thanks for your attention so far. I'm pretty sure I see a lot of appreciation for Matteo and his brilliant introduction to the foundation of the remote sensing and the basics that are always useful when we talk about the exploitation of satellite data. My role today is introducing you more on the business aspects related to how a company like Planetek brings value from satellite data to the end user. And I don't want to give you, because I assume you already had an introduction about Planetek from Matteo, and it will take a lot of time to discuss, to present to you all the different engagement of Planetek in the space industry. But most importantly, I just want you to consider that Planetek operates in different sectors, and our organization is designed to satisfy this market position. We have an internal team specifically working in the government and security, which includes public administration, defense, local entities like municipalities, regions, and this kind of authorities. Then we have a division that works with the so-called B2B business, which includes the engineering firms, the oil and gas companies, the water utilities, the transportation companies, everything that is around the engineering activities. Then we have another and last division working with the space-to-space activities that are specifically using algorithms and techniques to work on the payloads that are in orbit. Okay, so these teams are working in different ways. They can participate to specific projects. They used to work throughout all our 32 years of activities in different ways, which includes tenders, which includes the proposition of some capabilities. For example, Matteo is actively promoting our position in the defense sector, and in the public administration, for example. Recently, Matteo worked in a very brilliant project in the city of Taranto, here in Puglia, where we could combine multiple sensors analysis, multiple layers of analysis, including the water quality mapping, the vegetation monitoring, the stability of the infrastructure on the ground. So several different layers of information serving the different scope of monitoring for a municipality. Okay.
Excuse me
so
if I interrupt you, but Corrado Campisi here has to leave because he's taking a student to the station. We have got different schools, and so he needs to take the student back to the station. Okay, he just wanted to thank you. Well, here, okay.
Thank you.
Thank you for
Thank you,
this
Matt.
event, and sorry for this interruption. You
No
can
problem.
continue. Okay.
Okay, thank you very much, Matteo. Okay, so now I will give you a glimpse into what is called reticus. So Planetek, as I said, is engaged with the user, or is being engaged with the user for many times through projects. What is the difference from a project to a service? The difference is that when you are preparing a project, monitoring projects, you are putting together, you're getting the user needs, specific user needs for monitoring activities. You collect the data from satellite, for maybe other sensors, whatever. You prepare the infrastructure throughout this data will be accessible for a user. You set everything up, you deliver the service, you get paid. Then the service may have a certain period of time, 1 year, 6 months, or just one-shot delivery, depends. And then it concludes, it's over, it ends. What to do with all the effort that you made on the preparation phase, the rolling of the project, and the user engagement, etc. It's over. It's lost. When you operate through projects, generally, if you're not lucky enough to get the fund back and the extension of the project, generally the project ends this way. Probably you are familiar with something different, which is the service subscription, where you may subscribe, not and you pay even for your Netflix account, your Spotify. You don't pay for the infrastructure, for the items that are connected together to deliver something to you. You pay for accessing the information. And this is a game changer that revolutionized the software industries years ago. Okay, from Salesforce, for all the famous software you are using today are based on the subscription model. Okay, just for you to know, this was unapplicable on the remote sensing, on the space industries before mid let's say 2015. Okay, why was it not applicable? Because we hadn't enough satellites with data storage. Satellites were mostly used for specific capturing once they are committed. When someone pays to acquire the data, there were some programs for the continuous acquisition of this data, but it was not in place a standardized model for this acquisition and the sharing of these images outside the specific programs. This happened roughly 10-15 years ago. You have to be familiar with the Copernicus program, because the Copernicus program for the European Space Agency firstly transformed this concept, sending sentinels in space. the sentinels are continuously mapping all the world with different sensors. Those that Matteo presented to you are included in the Copernicus mission. And the policy for a company, or maybe the company that you will create tomorrow, is very easy. You can access, as you are European, you may freely access. If you're non-European, you may prepare some agreement, or it's very easy even for non-European to access these archives of data. But this is not enough. Once you have the data, you need the architecture. Unfortunately, Planetek has an extensive experience in projects delivery, those projects that we already mentioned. And so the infrastructure for hosting this data and transforming this data with different algorithms according to the scope of the monitoring, we already had that. And ultimately, what is very important in this transformation is the design of the service. Why it is very important? Because I just want to introduce to you a very important topic when we talk about delivering value to the user to a service. Probably you are familiar with Google Maps. Surely you are familiar with Google Maps. Okay. So if there's one thing I want you to grab for my speech, is this one. When you use Google Maps, you take for granted the GPS technology. You don't focus yourself on the mechanism. You focus yourself on the value of the information. How is that possible? Is that possible because you are the user, and who have designed the Google Maps considered that you don't have a background in GPS stuff. You don't need to have a background, and you need to satisfy your need of moving from one point to another point. Okay, this is what we do with Reticus when we want to bring a specific capacity of the satellite data exploitation to a specific market segment that I will show you some example in a second, where the user does not put his focus on the mechanism. He puts his focus on the problems that he has and how he can satisfy his problem. Okay, this is very important. So when we move from what on the same time, it's very important that the background is something that you must have to design such application. Okay, so who had at Google the controls of the GPS and all the other technologies were the technicians that made possible Google Maps, not the user. But you must have that kind of background. That's why Matteo introduced to you the foundation. So now let me share my screen, and everything that I would say would be much easier. Okay. First of all, okay, just a second. Here we are. First of all, do you see my screen? Please confirm. Yes.
Yes, we do. Yes, we do.
Nice Seiko. Okay. So first of all, why we use this famous, I hope you guys watch this movie called Back to the Future, for the Italians, Ritorno al Futuro. If you did not, please do it, because it's a fantastic movie, and I will use a lot of comparison with my generally with my presentation. In this movie, the technology, the time machine allowed the characters to move around different to travel through time. And this is what we do with satellite data. Today, we have archives of data that allow us to analyze the past. How many times this forest burned? How many times this area flooded? How many times this infrastructure moved how many times this area transformed from agriculture to buildings, whatever. Okay, so it's worth to analyze the past, but we use this to monitor the present, to understand, to take decision, and most importantly, to plan the future. Okay, so that's why I would like to introduce to you this topic about data, information, and knowledge. So we have the data, we have a lot of satellite data already acquired, and we are capable to acquire instantly or very rapidly today new images, but we have to transform them into information, extracting value from comparison or a single analysis. It depends on what we want to extract. And then we have to transform into knowledge. Knowledge is what gives you indication to the decision. Like Google Maps, go this way, not go this way because there's a traffic. That is a support through knowledge, okay? In this case, for example, there was an earthquake and you see how the buildings are completely destroyed or partially destroyed, so it indicates exactly the decision to take for the reconstruction. So Reticus is the platform that Planetek operates that deliver different services to different markets with this specific scope: predict long-term accurately and brings intelligence to the user. As you see on this curve, there are many other things where Planetek and the value of satellite data takes place, like in the data analysis, in the information generation, in the pattern recognition, in the classification, whatever, but not Reticus. Reticus is Google Maps for the end user. The systems behind the scene works this way. You have the satellite data continuously downloaded and continuously archived in our infrastructure, where not only the data but a huge number of different algorithms is already there, and it's ready to transform continuously this data into a flow of information that are fueling vertical dashboards where the knowledge happens, when the knowledge is accessed by the end user. Okay, so this platform is incredible. It was the first time that on the market a company ran. It was like 10 years ago when Planetek started Reticus, and is still today is one of the unique examples of such an incredible approach. And the user, as I said, may access this through subscription. So the business model, where of course my role, I am a business development manager, I engage with the user, I present to the user the value, and they are very happy to discover that they cannot pay for the creation of the information, but just for accessing them. First example, we have radar data. Matteo already introduced to you the value of radar data. Radar data is a black and white image. But if we perform a complex analysis that is called INSAR and includes a multi-temporal analysis of radar information, we can transform this data into ground motion mapping. So we can determine the stability of all the items on the ground to millimetric scale. How to transform this into knowledge? So these are data transformed into information, but how to make them useful through knowledge. This is what we do with Reticus Network Alert. When we determine, we help utilities to understand where the ground is stressing the path of their pipelines. So they can go there and investigate what the stress caused to their buried pipelines before it happens, what you see here, the hole in the ground, the collapse of the pipe generating problems. Okay? Would you please still confirm me that you see my screen, everything is okay?
Yes.
Thanks. So another example is another exploitation of radar data, not through the so-called interferometry analysis, but through another patented algorithm from Planetek that is capable to detect the integrity of electric tower systems. And this is very important because we worked, for example, with Terna, the Italian operator for the energy, that is very interested in assessing the integrity through storms to extreme weather events where they cannot send people, they cannot fly helicopter, they have no alternatives, and they needed this kind of capability always in their hand. And satellites, the radar data are capable to penetrate the clouds, to be ready anytime in any weather condition, and perform such an analysis through reticles. What we deliver here is a simple report. It's not a map, neither. It's not a platform, it's nothing. It's just a paper-based report that sends the integrity assessment on the desk of the manager. This is the long list of the reticle services that nowadays we have. As you may see, we have a long list of services approaching different sectors. We have also services for aquaculture, services for the wine producers, service for the wildfires, service for the marine monitoring, the urban dynamics, for the city planners. We have a lot of services. I'll give you through some example. I don't have time to go deeper all of them. I encourage you to visit our website and to understand more of this. But I would like to give you some cases that you can understand quite easily, and maybe get curious also on engaging some business proposition to the user. As I said, Reticus operates as a single layer of analysis, or it operates as a multidimensional analysis, because you have to consider that over a city where you are this very day, we can perform different analysis. We can determine if your building is stable. We can determine if the green around the building, if any, is in a good vegetation stress index. We can determine if the neighborhood where you are last year had less buildings, or it changed something in the geometry of the assets, etc., of the neighbor, etc. We can determine if the services that are below your ground, like water, gas, and other services, are receiving some threats for the environment. We can do a lot of things on a single building. Okay. First example, if you like beer, this one is one of the most famous brewery in Europe. It's called the Huber Brewery in Austria. This is an example of how to support the user through a complex legal procedure. They had this factory, this brewery building, and they started to have cracks in the wall, cracks such big that they had to stop the beer production. What happened? They called us to understand, with our reticus displacement analysis, if the ground around the area is being stable, or in a certain period of time there were some changes. And what happened is that we recognized that at a specific moment back in time, like 1 year before, they started a displacement. So the ground started to sink. And they immediately recognized that the parking area was started to be built right exactly in that period of time. Okay, so parking area building construction takes place. The movement is registered through our system. They could demonstrate that was the parking construction causing the problem to the brewery. It was such an incredible case. They could win the legal procedure in the court. We got an article on the paper and whatever. So this is the first example. Very, very easy. In this way, we prepared a very easy to access information through a paper-based, to a report that our experts prepared and delivered to the user. Okay. Second example, we are currently monitoring the bridges and the roads of the entire city of Sao Paulo, Brazil. This is me in the center visiting the control room of the Sao Paulo public entity that is hosted in the municipality of Sao Paulo. And as you may see here, there is a complex systems of cameras, sensors, people that go in field and inspect visually the integrity of the bridges and the roads conditions. And they are using Reticus safe way to prioritize the inspections with the same principle that I mentioned earlier. We can transform radar data into a multi-year, so we monitor the trends of the movement in a period of 10 years back in time, and every 3 months we update this information to give them a complete idea of where the bridges are stable and where the bridges are showing constant movements to millimetric scale, so millimetric precision. And they are very happy to have us because they could spread their resources throughout the city. You can imagine they have 10, 15, 20 people. They cannot go anywhere. They go exactly where it is needed. And we are that information. Then they install the cameras, they send people per constantly, whatever. But we are the trigger of all this process. Case 3. I already mentioned the pipeline monitoring. Hera in Italy started back in 2017 using our solution to prepare their inspection plans, especially in the sewage network, because you have to imagine that the sewage network are very, very big, and when they collapse, they create holes in the ground. So they are very, very sensitive to the ground motion. If you're pressing questions, please stop me because I cannot see the I can't see your raising hands or whatever.
Okay, unfortunately, our time is almost over because for students, in 10 minutes time, we're leaving school. We had, if we can, some questions here, some short questions, okay? Okay, first one. Okay, for you. Okay, the first one is from a student of ours, Ilaria.
Can you detect a substance like rocks? Can you detect a substance like rocks, minerals, seaweed into the melted ice from glaciers near Highland?
Through glaciers, there are surely applications of the radar. I'm trying to get the question that maybe Matteo can elaborate more. You have to consider that generally snow, it's a coverage, so it doesn't allow to see what is below the snow, as you can imagine. There are specific techniques of exploiting radar data that are capable to detect through glaciers, they can penetrate the soil, and they can estimate, for example, the amount of water below the ground. This technique has been used, for example, for finding water on the surface of Mars using radar data, or in other glaciers, glacial area in the Arctic zone. I'm not pretty sure there are applications of this in the industry for the mineral monitoring using satellite data. It's surely possible in the mining sector and generally in the mineral detection, applicate this, but not through glaciers on the different type of soil that are in the mining areas. Matteo, I don't know if you want to elaborate more on this.
No, no, Giuseppe, you're right. You're right. So I think doesn't exist the specific procedure to monitoring or mapping minerals, but in general, uh, probably in this case, you have to combine more ancillary data like a geological map or mineralogical map and the composition of geological place. Probably you can detect some feature like a color or maybe some signal spectra in the place, but it's so difficult. A good question. It's so difficult. Probably is a future goal. Probably.
Other questions? Thanks for your question.
Uh, I don't hear nothing.
I actually had a simple question. Out of how many out of the 7,000 satellites orbiting around the Earth do you Planetek own?
We don't own satellites. We are using data coming from satellites. So Planetek does not build and operate satellites. There are other companies doing this job and other space programs like the Copernicus one that I mentioned. In the 7,000 that you mentioned, are included commercial data and non-commercial data. Okay, so companies specialized in building satellites and sending them to space are doing so. Planetek access to these companies the satellite data acquired or may task. We have a specific control settings that allow us to plan to operate satellites for specific tasking of the data. Okay, you have to distinguish companies specialized in transporting, companies specialized in operating satellites and building, of course, and companies specialized in analytics and mapping activities.
Can you answer a question that is in the chat asked from the Afghan school, please?
Please, place the question. Sorry.
Yeah, if you could pick up with just one because we are out of time from the chat.
I saw the Bibi Madina make two questions and Zain Hab, sorry for pronunciation, make another question. So I think it's a good question. I try to connect both of the question in term of LEO and GEO orbits. So Zain Hub, I think in the future, GEO is the future in terms of if we try to connect the satellite together during the orbits, we can switch the problem that now the satellite have to pass through the ground station for give the data. If we connect together like a fishnet, you know, all the satellites, we can skip the problem that have need to satellite to round the Earth. But in general, I think LEO orbit is the most useful for Earth observation, not for transmitting data, but for Earth observation, because you know we have to revisit time for the same part of the Earth. And the second cloud measure barrier. Okay, to see through weather condition and what are trade-off data quality compared to the standard photo. I think the question of Bibi Medina, I try to respond to answer the second question, and if I understand well, you said me if Planetek utilizing SAR to see through the weather. Yes, we utilizing SAR to through the weather condition, and what are the trade-off data quality compared to the standard? Oh, so no, it's completely different kind of data. Okay, we can't use in the same way the radar data and the optical radar data, but with the it's a different use, really, because as Giuseppe said before, we use radar for ground motion segment, for analyze the stability of structure. We don't use this optical data. We use for environment monitoring. It's a different way. So it's not. We don't use SAR data, radar data, like optical. I think it's different way, but it's a good question. It's fine. It's fine. I agree with the question. It's right. Sorry. No, I don't.
So the time
Okay.
is actually over. Thank you so much for joining this meeting, and thank you for participating on it. We're, I think we will see you again in next future.
For sure,
And,
we will get in touch with you.
Yeah, we will keep in touch maybe by Professor Campisi between.
Okay.
Perfect.
For sure, and we keep in touch.
Students, okay, on behalf of the students and our colleagues, we wanted to thank you, a huge thank you. It was an amazing meeting. We had a great time with you. You covered so many important data, facts, and congratulations on the amazing work that you do with your company.
Thank you.
Thank you
And
very much.
we keep in touch with the mail and in LinkedIn too, guys. Okay.
Okay,
You
thanks
can
a lot.
connect with some
Thanks.
questions.
Enjoy your day. Thanks a lot and talk to you soon.
See you.
Bye.
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 Dica lei quello devo chiudere tu.